Morning students. So in this class we are going to discuss about dispersion of white light through a prism. So now white light enters into the prism, so dispersion takes place. So splitting of white light into constituent colors is called dispersion. So that is splitting of white light. So the white light is incident on the prism, so the refracted. So white light is refracted. So it is splitted into constituent colors. So from violet to red, so violet, indigo, blue, green, yellow, orange and red. So violet deviates more, red deviates less. So violet is most deviated, red is least deviated. So the colors obtained from the prism, so using dispersion, so it depends upon the nature of source of the light. So every color have a definite wavelength. So violet have a wavelength that is 400 nanometer, that is a shorter wavelength. Then red have a wavelength 700 nanometer. Then here green, yellow. So green have 5500, so 5890, that is yellow. So its nanometer, that is means 589 nanometer. So red have a longer wavelength, then violet have a shorter wavelength. So violet travels with smaller velocity in glass prism than red. Just see, so the deviation is less, so red travels inside the glass. So note the point, inside the glass prism, the red travels with high velocity, but violet travels with smaller velocity because of the deviation. So that is refractive index of that prism. So the dispersion takes place because light of different wavelength. So red have a wavelength that is 700 nanometer, then violet have a wavelength that is 400 nanometer, then green 5500, that is 550 nanometer, yellow 589 nanometer. So dispersion takes place because light of different wavelength travel with different speeds inside the prism. So dispersion mainly cause it's due to the different wavelength of that colors. So different wavelength of colors travel with different speed inside the prism. So for that, so violet have refractive index high, so it deviates more. So specifically red have a refractive index somewhat low, so the deviation is less. So in vacuum, so there is a dispersive medium, so inside the glass prism, so that colors deviates more and less, so the velocity is different. But in vacuum, that is free space, so all colors travels with same speed, that is velocity of light. So that is a light is a here electromagnetic wave, so electromagnetic waves travel with speed of light. So in vacuum all colors travel with same speed. Then speed of light is independent of wavelength in vacuum. So for example here that violet travels with shorter wavelength, so here the shorter wavelength, so violet have a travels smaller velocity in glass, but it have 400 nanometer. If it is in the glass prism, it have a smaller velocity. So if it is in vacuum, so violet travels with velocity, that is speed of light, that is 3 into 10 power 8 meter per second, that is speed of light. So whatever the color, whatever the wavelength of the color, so violet also travel with speed of light 3 into 10 power 8 meter per second, red also travels with same speed if it is in the vacuum. So if it is inside the prism, so all colors have, there is a different speeds, so that is due to the change in the refractive index high and low. Then finally, so Newton conducted an experiment using two prisms. He uses the first prism, so he passes a white ray and incident. So the splitting of white light into constituent colors, so violet to red, so violet deviates more, then red deviates less. So that refracted ray is again passed on the another prism that is inverted. So again here it is splitting, here recombination. So that VIBGR is again recombined into white light. So the splitting and recombine of VIBGR, so it's a famous experiment done by Newton. So in this class we will discuss, so what's my dispersion. So white light and incident on the prism, dispersion takes place. So dispersion mainly due to the light of different wavelengths. So violet have 400 nanometer, red have 700 nanometer, travel with different speeds inside the prism. So inside the prism, so different colors move with different velocity, but in vacuum all colors travel with same velocity, that is dispersion, splitting of white light into constituent colors, here violet to red. So the colors obtained from the prism depends upon the nature of the source of light. Here white light is used. So okay students.